All right, we're getting there. We're on the second last video. So this is video 21, which is a recap of ion concentrations. Makes you realize how much you learn in Chem 50. So ion concentrations is that the concentration of ions in a solution may be greater than the concentration of the compound. So we're talking about ionization. So we're taking a compound and looking at the ions that would be in solution. And we can use mole to mole ratios to calculate the concentration of ions as they dissociate. So for example, if I asked you to calculate the concentration of ions in the following solutions, ammonium phosphate is made up of ammonium ions and phosphate ions. So the first thing I would do is figure out the chemical formula for ammonium phosphate. So ammonium is that NH4 with a plus. My phosphate is my PO4, 2 minus, or is it 3 minus? I'm doubting myself. I think it was a 3 minus. Phosphate. Yep, 3 minus. Okay, so ammonium phosphate is going to be NH4 as my polyatomic ion, and there would be 3 of them combined with the PO4, which would have 1. Now, this is an aqueous solution, which means there's actually ions in solution. You would have ammonium ions and you would have phosphate ions. That is a B. And if you look at it, if we balance it, we have 3 ammoniums, so we would need 3 ammonium ions, and then only 1 of the phosphate. So then what they tell you is the concentration of the ammonium phosphate. So the concentration of the ammonium phosphate is 1.00, and then we're going to use our mole to mole ratios to figure out what would be the concentration of the ammonium ions and what would be the concentration of the phosphate ions. And so because it's in a 1:3:1 ratio, then the molarity would also be 1:3:1. So I would say that there is a concentration of 3.00 molar ammonium and only 1.00 molar phosphate ions. If you want to go through and do the whole thing, just know that because this is moles per liter, you're allowed to convert between. So if you're not sure what I did there, you could take your NH4 phosphate. So you have your 1.00 molar, and then you would do a mole to mole ratio. So it would be 3 moles of, oh, sorry, I put that in the wrong spot. It'd be 1 mole of ammonium phosphate, right? Because we're now going to convert from moles or molarity of ammonium phosphate into moles of ammonium. Fine, most people don't need to do this, but you can see that it's a 1:3. So that's why I took the concentration that was 1 and I just multiplied it by 3, whereas the 1:1 ratio stays 1:1. So pause the video, give the next one a go. So we've got calcium 2 plus, and we've got hydroxide 1 minus. So that's going to make a calcium hydroxide solution. That's going to be composed of calcium ions and hydroxide ions. Balancing my equation, I need 2 hydroxides. Then it tells me that I have a concentration of 0.500 molar calcium hydroxide. So that's going to be a 1:1 with the calcium, but it's a 1:2. So I'm going to multiply that by 2 and get 1.00, keeping the 3 sig figs, molar hydroxide. So it's as simple as that. You always start with 1 of the first substance, so it's really easy to go 1:2 or 1:3 or 1:4 or whatever it may be.